Hello, General Maths 3 students. We're going to do our first video lesson here, and this one's on nautical miles and knots. So rather than calculating distances in kilometres, we're going to calculate distances in nautical miles. So a nautical mile is, as you can see here, close to 2 kilometres. It's quite a bit longer than a kilometre, and it's even longer than a traditional mile, which is about 1.62 kilometres. There's a reason why people who are navigating the globe use nautical miles, and that's because they're quite easy to calculate. For travelling north or south on a line of longitude, the formula is just 60 by theta, the angular separation, which is much easier than doing the kilometres version of this formula, 2 pi by the radius of the Earth by theta on 360. So rather than using that formula that we learnt earlier or late last week, we're going to be using just a very simple formula, 60 times theta. Now, for travelling east-west, it's exactly the same, except we need to wedge in that cosine of alpha, where alpha is the latitude that we're travelling on, just like with the kilometres formula. So using this nautical miles formula is really quite simple compared to using the kilometres one. There's a note here about speed in nautical miles, knots. So 1 knot is a speed of 1 nautical mile per hour. Now, what is a nautical mile? Well, if you were to trace out 1 minute of angle at the centre of the Earth, 1 minute, not 1 degree, but 1 minute, so a very small angle, the arc that you would travel on at the surface of the Earth is 1 nautical mile. Okay, so let's have a look at a couple of examples on the next page. So here we've got a north-south situation, so we'll be using the first formula for this one, d equals 60 theta. Now this second example looks a bit different because we're told the speed of a jet. Alright, now that means there is an extra step to this one, but we still need to calculate the distance travelling westwards. Now because that's on a latitude and we're not going north-south but we're going west, we're going to use that longer formula. So with the cosine of alpha in it. Okay, so these are the two formulae for these two situations. You might want to try and try these on your own by pausing the video, and then I'll have a go at them afterwards. Okay, so I'm going to try these questions now. So for this first one here, we've got point A, which is 20 degrees north of the equator, yep, and point B, which is 35 degrees south of the equator. Does that look like a 3? Good enough. Okay, so of course one's north, one's south, so to get theta we'll add those angles. So an angular separation of 55 degrees, so the distance is 60 by 55. Which is 3,300 nautical miles. So just n dot miles will do for the unit there. Pretty simple. Okay, now this one down here has that extra step, like I said, where we need to consider this speed here. We're asked how long does it take. So we're asked about the time. So remember that speed equals distance over time, but we want to know what time is equal to, so we can use this triangle method, speed, distance, time, like this. And we want to know time, so we cover up time, and we can see that time is distance over speed. So if we divide distance by speed, that gives us time. So we still need to calculate the distance. We know the speed is 450 knots, we've got the speed, we've got that one, but we need to do a calculation for the distance. So we're going to use this formula here, and we've got that point A is from Greenwich 138 degrees towards the west, and point B is 110 degrees towards the east. So clearly we're going through this back way here. So we're going to subtract these from 360 to get our angular separation. So we subtract those from 360 and the angular separation is 112 degrees. So then we'll put this into our formula for distance. D equals 60 by the cosine of, it's 20. So there's our latitudes, cosine of 20. And then we multiply by our angular separation, theta, times 112. So when we put that in, we get 6314.73 nautical miles. Okay, so to get the time, we divide distance by speed. So time equals that distance, 6314.73, divided by the speed of 450 knots. And that gives us 14.0327 hours. Okay, so I'll just write that down up here. I'll just rub this one out. Make some extra space here because we've done all that working out. Okay, so 14.0327 hours. Now I'm happy with that answer there, but we could convert this to hours and minutes by giving it the DMS treatment in the calculator, just like you do for an angle. So try that, and what you should see is that this is 14 hours, and to the nearest minute, 14 hours 2 minutes. Okay, so have a look at the questions that are in the description for the video and try those, and then we'll work on the next video after that.